Hi everyone, and welcome to the Mempot Prac BMS 1031, where we're looking at the computer simulation of membrane potential measurements. My name is Ara Pinner, and in this short video, I'll be guiding you through the Mempot Prac software, referred to as Mempot, currently available to you through Monash Move. Before we make a start, I just want to briefly cover the purpose and aim and background of the Prac. We know we can take recordings of cells on the cell surface using a number of different measurements or methods. Some of these you'll cover in BMS 1052 next semester. One of these methods is referred to as patch clamping. Now, in this process, a micropipette is embedded onto the surface of a membrane of a neuronal cell, and the membrane is manipulated in some way, either by introducing additional concentration of ions through that micropipette, or by altering the charge internally and recording the changes that occur on the membrane using a reference electrode. Doing this process, however, is quite expensive, prohibitively expensive to that extent. Also, it requires quite extensive training over the space of many weeks to familiarize yourself with the experimental techniques and methods needed to perform such approaches. So rather than going through that process for you each individually, we've generated and put together a program called Mempot, which allows you to simulate those experiments that are performed in a wet lab setting in a cost-effective, simplified manner. So you'll be applying what you've learned so far in your lecture and workshop, and lectures and workshops on bioelectricity. And we are doing this using a computer package called Mempot. Now, there are two ways to access Mempot. Firstly, you can use the direct link that's available to you on your Moodle page. Or secondly, you can access it using your My Monash portal. So for me, I'll be selecting Monash Move using the tile located in the top right-hand corner. If I click on that, it'll take me to the Monash Move platform. It may take a brief moment or some time to load. Once it does load, we'll need to search for the package called Mempot. So all I've done is click there on search, and I'll type in Mempot. There it is. I've selected Mempot. It will take again some time to load, but once it does, it may ask you to opt in to whether you want to optimize your screen resolution. So it's just loading there at the moment, but rest assured, it will get to you shortly. And there it is for me. So I've already logged into this before. Let me just go back to the main menu. So for most of you, you might get a prompt before you see this screen, but essentially, this is the landing page of the Mempot Prac software. So you can see there's a number of different menu options. If you haven't read before watching this video or completing the Mempot Prac activities, I would recommend you view this first page on the introduction, which briefly outlines some of the stages involved in the practical. The key idea here is you'll be using, as I mentioned earlier before, just like you would in a wet lab prac, a micropipette to introduce concentrations of ions or alter the concentration of ions outside of that neuronal cell on the membrane surface. And this introductory pages here simply guides you through a background to that process. Cool experiment. So let's go ahead and make a start. And I won't show you entirely each stage of the experiment step by step. I'll just simply perform one repeat of it, and I'll let you, in your own minutes, to guide you through in your own time the remainder of each of those experiments. So let's make a start with part one, where we're looking at varying the concentration of just extracellular potassium ions. So we're assuming here everything else is kept constant, but we are altering only the concentration of potassium ions outside of the cell. So you'll see this landing page once you click on that menu option. On the left-hand side here, I've got what you would have seen typically in your lecture slides and workshop handout, an XY axis. The Y-axis represents the membrane potential. In the middle of the screen is our experimental play area. We can see we have a micropipette shown here and 5 individual examples of neuronal cells. These neuronal cells are embedded or fixed to a glass microscope slide. I mention that because it's important, and as you'll see, if I use this micropipette and penetrate through the cell, which is what I'm going to be doing for each of the 5 cells, I can actually penetrate all the way through and break the microscope slide or shatter microscope slide, which is not what we want to do. So imagine in this setup, I've got a micropipette. Within this micropipette, I'll either have different concentrations of potassium ions or sodium ions for part 2. I'm introducing those to the surface of the membrane cell. They're not actually passing through, not piercing it, even though you might see me pierce the cell. It's laying there embedded on the cell surface, the membrane surface of those cells. So I really don't want to be penetrating and breaking that slide, because I'm also trying to view these cells under a microscope at the same time. On the right-hand side there, you'll see shortly, once I start the experiment, options for you to control and manipulate this micropipette in either left-right movement or up-down movement. Similarly, you can also choose to use your computer keyboard and the up, down, left, right arrow keys, cursor keys on your computer keyboard. I'll be using both for illustrative purposes for you today. And importantly, as we complete these experiments, we've also got provided to us both the internal and external concentrations of our cations, namely the concentration of potassium and sodium inside and outside of the cell. As we take our measurements, you'll see these values here change. We've got our potassium concentration in this case out of the cell, currently set at 0.5, which is essentially 0.5 millimolars of potassium ions are within this micropipette, which we'll be introducing to the cell surface of each of the individual neuronal cells. And we've got the corresponding resting membrane potential values. We've got the standard error of the mean and a number of trials. So you can see here, I've already played with this data before. So what I'll go ahead and do now is simply click on Clear Data. You won't need to do this unless you've played with the data beforehand, before watching this video. But if you have, you can see now everything is reset back to default, and we're now ready to start. So I'll click on Start Experiment here at the bottom corner. And you can see it's going to ask you to enter in some values. If you look at your handout, you'll notice we're asking you to vary the concentration of extracellular potassium ions, shown here, between 0.5 and 150 millimolars per liter. So we'll start at 0.5 and we'll incrementally increase that up to 150 millimolar per liter. So let's have a look at those experiments. Let's start at 0.5, and for the purposes of this video, to keep it short as possible, I'll start and only look at what happens at 0.5 millimolars of potassium outside the cell. So you'll change that value by entering a different value into your keyboard. I'll start at 0.5, click OK, and now you're ready to start recording at 0.5 millimolars of potassium outside the cell. You'll notice those values there are provided to you. Inside the cell, potassium ion concentration is 150 millimolars. The sodium ion concentration inside the cell is 15 millimolars. And out of the cell, you can see we've set it to 0.5 millimolar, and the concentration of sodium ions out of the cell is 155 millimolar. So let's go ahead and start moving and start generating some results. So to do so, as I mentioned, all you need to do is use the cursors shown here. You can see I've penetrated the cell. If I go all the way down, it actually damages the cell slide, cell membrane microscope slide, as well as it shatters the micropipette. Not good. So let's try that again. This time I'm using the keyboard cursors. You can see I've penetrated the first cell, and on the left-hand side again you can see it's provided me a recording for our membrane potential as I pierce that cell. Second cell, third cell, fourth cell, and the 5th cell. You can see there, once I've done all 5 cells, the individual membrane potential values recorded for each of those 5 cells respectively. We'll now be able to plot the average of those curves, which is basically shown to you here on the left-hand side, and provided to you on the right-hand side display. So the average of those 5 values is equal to negative 97.2 millivolts, and you've also got the individual values there for your measurements. So what you need to do, and importantly what you need to do, is write down these values, 0.5, negative 97.2, 2.6, and 5 in the table provided to you in your worksheet, or if you prefer, into an Excel spreadsheet. You'll now go ahead and repeat that for the remainder of those values. So you start with 1, 5, 10, 20, 40, 100, and 150, and repeat that experiment again for each one of those measurements.